One of the applications of simultaneous equations is the opportunity to complete a break-even analysis. This is where we look for the break-even point, and this occurs when costs of a product or item equal the amount of income that's brought in by selling that item. So this is the break-even point, or this is where you are breaking even. We could also say this is the point where you are not making a profit, but you are also not losing money. We could also calculate profit, and we use the formula income subtract costs. So to make a profit, we need to make sure that the income is higher than the cost. Income is calculated using the formula I equals mx, where m is the selling price and x is the number of items sold. Cost is calculated using the formula C equals mx plus c, where again m is the selling price, x is the number of items sold, and c is the fixed cost of production. So to find the break-even point, we are graphing these two linear equations and we are finding the point of intersection, as seen here. So as you can see, there is a line of costs and there is a line of income, which sometimes is referred to as revenue. And the break-even point is the point of intersection. Anything above that point, we are making a profit. Anything below that point, we are losing money. The other important component of this graph is to notice that the unit sold is on our x-axis, and that is the value of x that we have seen in our formulas. Let's use the graph to complete an example where we can find the break-even point. So Grace buys and sells wallets. Income received by selling wallets is calculated using the formula I equals 30x. Costs associated with selling wallets are calculated using the formula C equals 20x plus 30. Firstly, use the graph to determine the number of wallets Grace needs to sell to break even. And then, how much profit or loss does she make when 4 wallets are sold? So let's complete our first question. And it says to use the graph to determine the number of wallets Grace needs to sell to break even. And to be able to do that, we need to actually look at our graph and read the point of intersection, which will give us the break-even point. So read the point of intersection from our graph. And if we have a look here, it's this point. And so we need to find our coordinates of this point. So if we go down our graph there to our x value, it's 3. And if we go across, our y value is 90. But what we want to know is the number of wallets, and that is actually our x value. So if you have a look, our x value is 3. So Grace needs to sell 3 wallets to break even. The second part of our question says, how much profit or loss does she make when 4 wallets are sold? So if we look here, we're looking at 4 wallets on our graph, which lies on our x-axis. And what we want to do is read off the graph our income and our cost for 4 wallets. So if we go up the graph and at cost for 4 wallets, it is 110, and the income for 4 wallets is 120. And if we remember that profit formula, we need to subtract the income from the cost. So we can now substitute our I value and our C value. So income was 120 and the cost was 110, and if we subtract those, we get $10. So Grace actually makes a profit of $10 when she sells 4 wallets. So this is using the graph to find the point of intersection and to also to be able to find the break-even point as well as the profit. The other strategy to look at is to use algebra, and we're going to see an example here. So a firm sells its product at $20 per unit. So we can actually write straight away our income. We can write the income formula, which is I equals 20x. And it says the cost of production is given by the rule C equals 4x plus 48. and x is the number of units produced. So the first part of the question says find the value of x for which the cost of the production of x units, so the cost, equals the income or the revenue received. So what we're going to do is we're going to solve these simultaneous equations by algebra. So if you remember, the first step is to number our formulas. And what we're going to do, just like the question suggests, is we're going to make them equal each other. So we have 20x equals 4x plus 48. And what we want is all the variables on one side. So we'll do 20x subtract 4x equals 48, which gives me 16x. And then 48 divided by 16 will give me 3. So it says find the value of x for which the cost of the production of x units is equal to the income or revenue received by the firm for selling x units. So the break-even point for this product occurs when we sell 3 units. So that's the answer for A. Now B says we need to check the answer algebraically. So if you remember, what we'll need to do is substitute x equals 3 into each of the formulas and see that they actually equal each other. So we can put it into the I formula, so 20x, and wherever there's x, I'm going to substitute the value 3. So 20 times 3 equals 60. I'm now going to substitute the value x equals 3 into the cost formula, and what we want to see is if we've solved this correctly, that C also equals 60. So 4 times 3 plus 48, and we do bid math, so 4 times 3 is 12, and 12 plus 48 is 60. So as you can see, both formulas equal 60, which means that they both intersect at the point of x equals 3 and y equals 60. And this is the break-even point. So if we had to solve this, it would be 3, 60. The other strategy to complete this particular question would be to graph the two formulas and read off the graph the point of intersection, and then you would substitute the values in and do exactly what we did here to check that they were correct in that both equal the same values in the end.